Akash. My name is
Hello.
Shakti. I'm working in Walmart. I have having 8.5 near to 9 years of experience in data engineering domain.
Okay, yeah.
So I have worked both as a full stack developer as well as a data engineer. So we will be starting the interview. So can you tell me something about you and your professional journey?
Yeah, so thank you, Shakti. So actually, I started my career in 2018, and
Okay.
since then, I am in data engineering field. So it's around 5.5 years of experience in data engineering. So I started my career with Apache Spark, which we used for the integration of various sources of data to a data lake. So that I started with that. Then I learned about. I moved to Apache Spark which I use to transform the huge amount of data. And after transforming the data, we used to push that data to the data lake. After Spark, like lately in my career, I also worked with Azure Cloud, so Azure Data Factory and Azure Databricks for doing the same things basically on the cloud. So this is a nutshell the technologies which I worked on, and including the projects, like I was more in the fintech projects where we used to handle different transactions between the customers and vendors. So yeah, this is a little bit about me. Yeah.
Okay. So from the beginning, you are having pure data engineering experience, right?
Yes.
So, how was your journey for this 5.5 years of experience? Means tech side, like how are you moving to the newer technology side, or are you only concentrating on the legacy technologies?
No, I am moving. So if you see my career, I started with NiFi that was Corely for ingestion, then moved to
Okay,
Spark for the transformations, and now I am moving. Like lately in my career, I also learned or explored Azure Databricks and Azure Data Factory, which is basically the ultimate or the new thing which the industry is going to follow. So yeah, I got chance to work on those as well. So I'm having the combination of both on-prem legacy systems and the cloud as well. So yeah, both.
okay. So, what is your aspiration? Like, what technologies in future will you be willing to work, or are you looking forward?
Mainly want to move towards cloud. Like we have different Azure services, like something like Azure Synapse and LTX, which is a data warehousing, and it itself has a different function. So I would like to explore more into it, and any Azure service, any cloud service, basically. And that too is not limited to Azure. If there is any cloud service, where I can go more into the data warehousing parts or more.
So, are you comfortable with SQL?
Yeah, I'm comfortable. I would rate 4 out of 5. Like
Okay,
yeah, that's it.
got it. So I will be sharing one question for
Okay.
SQL. Can you just share your screen and open a notepad or any text editor?
Yeah, I guess yes.
Just copy the question and let's start. Means you can go ahead and write a query for this.
Okay.
You can copy that entire question in your
Okay.
notepad and then you can start.
This managers. This is manager ID. This is the employee ID. Okay.
So just read the question thoroughly and let me know if you are not able to understand. I can.
Okay.
You are able to get the question, right?
Yeah, I'm able to get the question. Just okay. Uh, just try.
Yeah, just try approaching it. Even if it is not syntactically correct, it's
Hmm.
okay. But let's see if you are able to get the correct approach.
Yeah.
You can click on that pen button.
You,
Just
you can speak another one.
yeah. Just to give you a hint, you can use subquery to resolve solve this, or else you can also use self join.
Okay. Yeah. Um, can you? Okay, so maybe you're not. Maybe let me share my screen again because you. Yeah, I'm actually. I was doing it in another tab. That's where you might not be able to see. Can you see my screen now?
Yes.
Yeah. Yeah. I think I get the. Mm.
So in this solution, can you explain me the solution?
Yeah, so what I was doing, I was basically it's doing a self join where for each of the ID, like for each of the ID, I am searching the manager ID in the another table. Like if I take this employee table A and B as a different tables. So what I was doing is I was just searching each of the ID and want to join it with the manager ID of the other one. In that way, I would get the IDs of the other table where which itself is the manager of the current ID. And by then doing a group by, I can find out like which of the rows have more than five managers. So in that way we can find which of the row has
Okay,
more than five direct, like kind of a direct reporting.
okay, got.
Yeah.
Okay, so can you explain me in PySpark like how you are writing a pipeline end to end? Like what is your source, how much data you are handling, and what type of transformation you are doing?
Okay, so basically, like we have this multiple data of customers. So it's like what happens is in our project, customer is the purchase orders. We get into that into our warehouse, a common repository, and then we send that purchase order to the corresponding vendor. And again, Quilter will send us the purchase order acknowledgement, and we will send that purchase order acknowledgement to the customers. So we have the large repository of data where we have a lot of customers data as well, which is raised PO, which are raised by them, and PO acknowledgements which are raised by vendors basically. So like for ingesting the data for getting off, so this is one of the tasks which we have, like to get the data and transfer it to the target location. So for getting this data, we use Apache NiFi in on-prem, and to some extent, like in cloud, we use Azure Data Factory as well. And when we have all the data to the central repository, what we do, we push all the data to the data lake, and after when the data is present in data lake, we get the data by using Pyspark and do the transformations and the analysis or on the filtering of those data and push that data to the again to the HDFS, or if the project is on cloud, we push that data to the Azure Data Lake storage. And that data, after that data can be used in two ways. One would be by the data science team, and another would be by the analytics team, which is a data warehousing team. That other there is another team which just fetches the data and do the corresponding insights and the analysis. So that's how it works.
So the data ingestion part,
Yeah,
you are using a tool.
right.
So does the data transfers means what is the true source of the data? Is it a application or
It's
is it some file based scattered file
we
based?
Yeah, so we have different type of sources. So different vendors have their own systems. So yeah, they provide it in a different way. So some vendors have the data in relational DB. So we
Okay,
just query the data and get that data. Some send us the daily files in the SFTP form. Some of the
okay.
vendors has provided us the API. So we cater with different source of different types of data for this.
So the Apache NiFi which you are using,
Yeah.
does it handles all this type of scenario, or are you
Yes.
using Spark native
Mm, no, it handles
library?
all the kind of scenarios, but for the transformations, while fetching the data from the data lake systems, once we get all the data to the data lake system, then we use Apache Spark for doing the transformations and for the analysis work. For creating
Okay,
certain, it could be certain reports. We create certain reports out of it, uh, and then we use Apache Spark.
okay. So in Spark, what type of transformation do you do on top of the data?
So it's mostly we start doing it by doing the filters, removing the duplicates or filling the null values. Then then it's mostly like a group by or joining multiple tables, joining multiple data frames to create a report. So it's mostly the joining the multiple table data in this part. And after when we have joined, we basically perform some of the group by operations to just create the report out of it. Like for example, how many vendor POs are there for a particular day? How many vendor POs were rejected? These kind of analysis we do, and we again create a folder in the data lake for that particular vendor.
Okay.
Yeah.
So these are basically narrow transformations. Are there any wide transformation also you are using?
Yeah, so like group by, which when we use, it's the Y transformation. So yeah, why will we do the group by, it's a Y transformation, and to some extent join as well. So earlier join used to be kind of a Y transformation, but later we optimize it so that the shuffling doesn't happen. But whenever we do group by, still it counts in the Y transformation.
Okay.
Yeah.
So what's the difference between narrow and wide transformation?
So wide transformations basically means if there is shuffling involved between the nodes, then we call it a wide transformation. Narrow transformation
Okay.
could be when there is no shuffling involved. For example, filter could be an example of a narrow transformation. Group by, when
Okay.
we, because we, if we want to group by on a certain column, we have to check the other partition as well. So that in that shuffling will be involved, and that's where that's count in a wide transformation.
Okay. So since you are using group by, there will be shuffling.
Right.
So it compromises the uh, processing speed because obviously there is a IO operation
Yeah.
happening in the group by. So how you optimize it? Like when suppose for example you are having a data set,
Hmm.
you get the list of transformation you are going to apply.
Okay.
What sorts of technique you use so that the whatever process you have setting up, that's the optimized one? What sorts of performance enhancement you do?
So one of the tasks which I do is basically like filtering the unnecessary data as soon as possible. Before doing any operations, it used to do filter, and then we have to do group by. So we have to ensure whenever we are doing a group by, like we check the sample data and see in this Spark UI if there is any partition skew happening, or if there is any operation, there is any partition which is taking a lot of time. Then if it is happening, then accordingly we take decisions. So, for
Okay.
example, let's say if one of the partition is taking a long time, then we understand, okay, there might be a partition skew. So we use some of the Spark techniques like adaptive query execution if we are above 3.0. Otherwise, when earlier we used to do sorting techniques to just resolve it. Even if after that it is not resolved, then we might go ahead and try to increase the number of shuffle partitions. And if that also doesn't work, then maybe increasing the resources to optimize the entire pipeline.
Okay.
Yeah.
So there is a concept of coalesce and repartition.
Yes. Yeah.
So can you explain me what's the difference and where are you using if you are using that in your pipeline?
Okay. So Coalesce. So there were certain scenarios when we so if let's say we, for example, in Spark by default there are 200 shuffle partitions. Okay. So let's say if we want to, sometimes we want to just reduce the number of partition, we go ahead with Coalesce, and if we want to increase it, we go ahead with repartition. And this is not a general rule. In some cases, even for decreasing, we might want to go ahead with repartition if we are sure, okay, we want parallelism. So what happens is Coalesce will restrict the parallelism, but using repartition we can just reduce the number of partition, and also we can achieve parallelism there as well.
Okay.
Yeah.
So you are storing the data as a file or are you loading the data in some tables in the data lake?
No, we are loading it as a file. So, in the data lake, like in the Azure Databricks, we are just storing the files in a Delta format. Sorry, yeah, Delta format. In Delta format, we are storing the files.
Okay. So uh, there are all the other file formats as well,
Right.
like which is more optimized and all.
Right.
So what business need are you solving by storing it in a delta format? Is it
Eh,
like a need from the business or is it suitable for your application?
So, as I told you earlier as well, like target system, after we push the data to the target system, there is another team which would use the data for their data warehousing systems. So the most optimized way which we found was the delta. So it's an additional processing layer over a normal normal ADLS, which would make it efficient, then which will make it more efficient to process the data. So if we use, and also there are certain properties which Delta provides, like the acid transactions, which the other system doesn't provide, the data lake system doesn't provide. So to achieve that, we was does decision to pull to use the Delta format. And
Okay.
yeah, earlier we used Parquet, which was again very suitable for Spark. But when we moved to Azure Cloud, yeah, Delta made more sense.
Okay.
Yeah.
Okay. So, how you decide, like, as a developer, are you also get involved in deciding the memory, executor memory, driver memory, and all the other resource availability for your application? So, if you are involved, how you decide that?
Yeah. So first of all, like we see how much data is there, and what are two things which we need to take care before deciding this. Like how much data are we going to gather, and how many transformations are there, whether there are any caching or not. So based on these three factors, we decide like how to initially allot the number of resources. So we do a performance test again and again. Like if we, for example, if I have a 80 GB data and we have a 14 node cluster, so we would just take like number of resource. We will just experiment with the number of executors, and then if we see okay there are more optimizations needed, we will just increase it, or we will decrease it if we found okay this could be done in a very this could be done in a short resources as well.
Akash, I'm not able to hear.
Is it hello? Am
Can
I
you just repeat last 1 minute? Actually, it got break.
okay? Am I audible now?
Yeah, yeah, you are audible now.
Okay, so basically depends on the data. How much data do we have? Okay, how many transformations? Whether there will be any caching involved or not. How many transformations are there? Whether there will be any group by any wide transformations involved or not. Based on these two factors, and how much resources we can allot for that particular job. Based on these three factors, we go ahead and decide the number of resources. We try running it, and if we encounter any issues or if we feel okay there are extra resources available. For example, our job might require only 100. It's okay, our initial partitions are only 100, but we have provided 200 cores. Okay, so that's the we are not using them, so we'll just reduce them, and we'll see if we further will need any number of cores or not. If not, then we'll just reduce them. So it depends on the execution. We'll check the Spark UI,
Okay.
how we can get it. Yeah.
Okay. So, big data is like we cannot know that every day the data volume will be the same. So, have you
Yeah.
faced any type of scenario when there is a sudden spike in the data volume and it is failing your system? And if yes, then how are you handling that?
Yeah, it happens like to most of the cases. Like so, it used to happen in cases like if we have given uh, let's say if we have given 4 GB for one partition. Okay, now that in that case, if we are using if so so f- not so okay, so to be very precise, if we have given like around 1 GB for a partition, so we consider okay each partition could be a 128 MB, and then it might if we have given that 1 GB for that particular partition, then it might be able to anchor. But if sometimes the partition size increase because of the group by and all, then this there might be a disk spill, and it might create problems during the execution. So yeah, in that case, we have to go and check if what we can do, whether we can resolve the partition queue, or we can increase the number of resources. Can we provide something like 2 GB for that particular partition, like the total memory, so that it can handle it? So yeah, we do that. We try to optimize it in a way if we found any.
So, in some scenarios, like you have optimized your process and made it the application to handle 80 GB of data,
Okay.
for example.
Mm.
And if in some scenario, someday there might be like 160 of GB of data coming at a time.
Okay. Yeah.
So have you faced this type of scenario? Like not 10%, 20%, all of a sudden, if the data volume is like increasing more than 100%. So have you faced this
Mm.
type of issues?
Not exactly. So whatever I faced, it was only on the a little bit here and there, but not that much.
Okay. Okay. So you are handling mostly the relational data. That's the
Yes.
reason the
Yeah.
data volume is not increasing that much.
Right. Right. So it's almost that only. The
Okay.
estimated are that.
Okay. Got it. In your overall Spark process, what are the optimization technique? One, you told that you reduce the number of partition whenever there is data skewness. So,
Mm.
what all other techniques do you consider while writing a application?
Most okay, so if I see the code, if we start writing the Pyspark code, one of the things which we would do is again the filtering of the data at the very first level, so that we get at the less the number of data, of course. Okay, that is one of the things which we should do. Whenever there are joins, okay, if there are if the other table is of less data, less, so if the other table is less, we should go ahead and do the broadcast join, so that there is no shuffling involved. That is one of the techniques. In broadcast join as well, the by default there is a size limit, like the other table should be of 10 MB. And let's say if you in your case it is that other table is of 11 or 12 MB, then it still makes sense to just go ahead and do the broadcast join. So we should force the broadcast join if the Spark is not doing the automatically in certain cases. If we have two large tables around it, we should not do a direct join because it would again involve the shuffling. So we preferred the SMV join, where we partitioned and bucketing both the large tables, and then we do the join, so that the so that doesn't involve the shuffling much. Yeah, and another would be the hash. Try to use the aggregate instead of a sort aggregates whenever we are aggregating in Spark SQL query. We go ahead and try to solve. Okay, can we do it in hash aggregate? So yeah, if possible, if the number of distinct values are not that much, we try. Okay, let's do it in hash.
Okay. So, mostly whatever processing you are doing,
Yeah.
are you handling full data refresh type of function application or incremental application?
It's a full data load. So what happens is in most of the cases, there is another team which just pulls the data to our data lake, and our job is to just get that data. So yeah, so it's a daily report. So we can say like there is one 867 ETI 67, which is basically the resale report of a certain resellers. So there is another team which will just gather all the resellers data and just dump it to the data lake. And our task is to create the uh, report out of these H7 data and combine it with some other tables like the warehouse data, so that the analytics team can understand, okay, how many more parts do we need, how much is the requirement, what could be the future business. So these are the very crucial insights for the business, which we help to solve that.
Okay. So, have you ever worked on any application where you are having correlation with the past data as well? Like you want to, suppose, for example, upsert, if you want to update or insert the new records. So, what type of technique do you use to optimize it if you have done those type of work?
So it's mostly on creating reports, not we have this existing data. Either so I've done two type of work, either for the ingestion for getting the data in NiFi, or in the data factory. And whenever we have processed the data, it was mostly on the reports to create the crucial reports. So yeah, the upside directly in the DB or in the data lake, I haven't used.
Okay.
Yeah.
Okay. So you are storing the data in delta format.
Yeah.
Previously, you were using Parquet.
Right.
So, do you know what other formats are also there which are optimized to storing large amount of data?
Yeah, so sometimes as far as Spark, for the core Spark, like the we should it depends on the business needs as well. So if we want to, if we are reading the file from somewhere, if someone is reading the file, we should always use the columnar format. So that's where we use Parquet. And there are like with the Hive, if someone is want to use, they want to go ahead with Evro. So I like the optimized part. I know like Parquet is really useful. Parquet, and then if I go to cloud, the Delta format. So we mostly dealt with Parquet and Delta, and and for the Hive they might use Evro or ORC. So I'm aware about those, but I mostly stored data in the Parquet or Delta format. But
Okay,
there are other
so
formats like Evro and ORC as well, which
mhm,
teams use. Yeah.
okay. So we are having also ORC like Spark can also store the data in a ORC format.
Okay.
So what means additional benefit you got by storing the data in Parquet?
So Parquet for Parquet, each file there whenever we are storing the file in Parquet, we get this extra metadata along with the main data. So what happens is like every file in Parquet, it's divided into the chunks basically. So if we have let's say 100 MB of data in a Parquet file, might divide that data into the 25 MB of chunk. And even in that chunk, it will store a little bit metadata like the min value, max value, count value, all these things like the metadata. And whenever we are querying that file, it becomes really easy to query it because then it doesn't have to scan the entire data. So let's say if I want to find, if let's say if it was a CSV file and if I want to count the number of records, I will go ahead and actually see how many records are there. So in terms of complexity, it might be ON complexity, like where I have to go and search each and every record. But in case of Park, it's open. No matter how many records are there, it will give me the result very quickly because the metadata is associated. Even if in the chunks the metadata is associated, it becomes really easy to find the min max between the columns as well. So yeah, there are some additional benefits for the querying, and also there is one more trick here. Spark supports various compression techniques. By default, is snappy, so they have these lightweight compression techniques, which makes it really super efficient for the storage purpose. So yeah, that is also Spark provides.
Okay.
Yeah.
So, as a data engineer, means are you also using data structures for the processing, uh, like maps, list, arrays, anything in your application?
No, not as such, not directly. We are just using the core Spark. Yeah.
Okay. So, you are not using that, but there are many use case like there can be many applications where there might be need of storing some data as in a some data structure like
Okay.
some array maps or something.
Yeah,
So
yeah.
can you think of any scenario where you may need those type of
Yeah,
uh,
so internally we use, right? So for example, let's say we want to group by to a certain, we want to do a aggregate or a count of, for example, let's take an example. We have this employee table where we have employees and department, and we want to know, okay, how many employees are there for each department. Then it really makes sense to use the hash map basically, or the dictionary to just count it rather than doing other techniques. Then it really makes sense. So there we can use hash map. uh, some of the techniques like if we have this sorted data and we want to find a certain number, we can use the data structure like the binary search tree to just search it, because then we have some data, we know what's the min max values, and then we can go ahead. So yeah, these are some of the tricks which we can use if needed.
okay.
Yeah.
Okay. So can you write a PySpark application to read a text file or a CSV file or any file, any format,
Okay.
and to get the word count, like the count of each word.
Okay, okay, I can do that.
You don't need to be syntactically correct, but you can write the pseudocode and explain me what is happening behind it.
Sure. Yeah. Hmm. So let's say it's a CSV file.
Okay.
Okay, here let's say it's the path, and we'll just get the data to the path. And okay, so let me think. So yeah, so if we have a CSV file which would just contain the list of words, we can simply group by using that particular column if we have that word column. If the file is something like this.
No,
Yeah.
what I mean is we have a text file. It is
Okay.
having rows, lines of words.
Okay. Okay.
Like, for example, this whatever you are showing, right? For
Yeah.
example, that's the file. So
Okay.
there is select, there is a dot name, there is from and all.
Okay.
So just write a function to read this file
Hmm.
and to count the number of words, like select is occurring one time, group is occurring one time, like that.
Okay. Just a minute if I have to die. If I need to think.
Okay. Yeah.
uh, this file. Text, this. Actually, I would get that in the columnar format. Like if it's in the words,
S-
if I have the
Okay.
text file.
So for the hint,
Yeah.
you need to create a RTD,
Yeah.
then split it with respect to space. so that you get a word RTT. Then you
Yeah,
need to use some
group by
functions.
or reduce
Yeah,
by. Yeah,
you need to basically use map
yeah.
to map it each word to a number, and then use group by or reduce by. So if you can just write that.
Okay. Should I get this data? Need to have this in space separated form. Okay, okay, now I got it. Uh, okay, yeah, it will give the counted data.
Okay. So can you just explain me what is happening here? What are these functions? Like you use split function, map function, reduce by key. What are these functions doing?
Uh, so basically, what it will first one would just split the data and make it a list. So let's say if I have something like Akash is a data engineer and then Akash, so it would just list the make it in a list. So it would be different words in list. Like Akash would be one of the element of list, then is and a data engineer. So basically, that would be the splitted data. And then what we are doing is whatever map, so if I have this data, let's say if I have this, and then something like this is happening, then the second one would just create a tuple out of it. So it would just make like this. So just getting two example, and then if I just take one more, let's say if we have one more word with Akash, it would be like this. Because we're just assigning one value, and then when we do a reduce by this x is basically the sorry, so it should be I think um, okay, sorry, it would be x only. So yeah, this x would be basically the key, and then it would just sum up the data using this lambda function. It would just take the value of one value of here, and it would make in the end something like this. So yeah, so it should be this.
Okay. So here the data which is getting created when you are spark.read format text and you are passing the path. What is that means? Is it what type of data structure it is? The data object which is getting created.
This one, okay. So internally, this Spark. So the first one, right? This data. So it's internally in this.
Yeah, the
Yeah,
data.
it's this Spark RDT internally created in this
Okay.
particular case. Yeah, and later we are
Okay.
using this list and the tuples.
Okay. So this is a RTD. So how
Yeah,
the RTD is stored in the memory? Because Spark is known for the distributed data processing. So how
right.
this RTD is stored?
Okay, that I am not aware about. Yeah.
Okay. So do you know that there are three formats like RTD, dataset, and data frame?
Yes.
So probably you might be in your application creating data frames since you
Yeah.
are using the relational data.
Right. Yeah.
So what is the difference between these three? Do you have that
Yeah,
data?
so basically like Spark has this two kind of APIs. One is the low level one, which we call RDD, that is resilient data set, I guess. Yeah, so that is that, and the second is data frame. So data frame internally uses RDD. It's just when we combine RDD with certain metadata. So if we see there is no metadata like the column names or something in this case. So if we combine the RDD with the metadata, it's basically the data frame. So data frame internally uses RDDs for its application, but it is quite easier to use data frames. And
Okay.
dataset is I guess when we use Spark with the Java or any of the very what syntax associated language like something. So what happens like say dataset need to be compiled properly before executing. So yeah, that dataset is a quite dataset are the part of high level API. That's just that when we're using Pyspark, we go ahead with we use data frames. And I guess
Okay.
when we use Spark with Java or Scala, we go ahead with dataset. But dataset I'm not much aware about. Yeah.
Okay. Got it. Okay, Akash. So we are good with the interview. So if you
Okay.
have any questions, you can ask me.
Yeah, yeah. So just wanted to know like what would be the project in which we will be working. What's the project? Can
Okay.
you tell me more about it?
What type of project are we working in
Yeah,
Walmart?
yeah, yeah.
So Walmart handles a lot different type of data. It may be customer data, finance transactional data, or merchandise data, item data, anything. It's a very big enterprise, so there is every sorts of data.
Okay.
So as a data engineer, uh, we don't work in a specific type of data set. It
Okay.
will be like requirements will be coming and it keeps on changing. Sometime we may need to fetch the data from an API from an open source application
Okay.
like some US government's website and publish it to our data lake for the business.
Okay.
Sometime business might be sending us the data, we will be just processing, rectifying, correcting, checking the data quality and loading it. So it will differ as per the different use case, whatever the business has.
Oh,
As well as this is related to the data pipeline. We also own couple of application end to end. Like we will be the owner of the application. We will be consuming the data and generating some business insights also,
oh,
and different business people they will be leveraging our portals to validate the data, like for global investigation we will be investigating what type of data, whatever data we are fetching, the end user will be investigating that. So as a data engineer you will be seeing all sorts of work there.
Okay. Okay. Got it. Yeah. Thank you so much.
Yeah,
Yeah.
yeah. Any other question?
No, no. Thanks a lot. Yeah.
Okay, yeah. Thank you. We will share the feedback in some time.
Yeah,
Uh,
sure. Okay.
okay,
Thank you.
thanks.
Okay. Bye. Yeah.
Yeah.